Consider a solution that is basically NH4NO2. Okay, NH4NO2. What is the pH of the solution? The first thing that you do is break them down. مثل ما حكينا بنمبر 32 اللي حطيته number 32 part خليني أقول 0. Okay, break them down. This will break into NH4 plus and NO2 minus. If you don't know mean weak mean مش weak تطلعوا على Ka. If you have the Ka given, it means that both of them are weak. So I have the Ka of the acid given and the Kb of the base given. So basically both of them are weak. But pay attention that the Ka of the acid is 10 to the negative 10, while the Kb of the base is 10 to the negative 11. It means that Ka of the acid is actually greater than Kb of the base. It means when you compare the acid and the base, the acid is stronger, even though both of them are weak. If the acid is stronger, it means that the acid will control the pH of the solution and the solution will be acidic. Okay, very simple. هيدا اللي حضر أول part من number 32 will know why. Number 44. Which of the following statements are correct concerning a buffer? And for this, we have to read every statement. Pay attention. The pH of a buffer solution is very sensitive to moderate dilution. Is it very sensitive to moderate dilution? No. In fact, a buffer, okay, ما حدا يفتح المايك من عنده. A buffer is a little sensitive to extreme dilution. So for example, إذا كان أنا عندي buffer that is 5 molar and I dilute it completely, like maybe to 10 to the negative 10 molar, then yes, the buffer will lose its خليني أقول optimal function. But it is sensitive to extreme dilution, not moderate dilution. The buffering capacity of a buffer increases upon decreasing its concentration. This is actually the exact opposite. The more concentrated a buffer is, the more efficient it is. So كمان this is false. Upon mixing n moles of weak acid, هنكتبها حتى ما تضيعوا. عندي n moles of HA and n moles of HO minus. Look, n equals n. قبل ما تكفوا, what will you have if you have HA plus HO minus in complete values? خليني نكتبها as a reaction, it's better. HA plus HO minus. Part 3 حطيته N. هيدي أكيد will give me A minus plus H2O. What happens if you add N and N of HA and HO minus? طبيعي, you have a complete reaction. Both of them will be consumed, and what you will have in your solution is just A minus. So N moles of HA and N moles of sodium hydroxide will completely neutralize each other. Will you obtain a buffer solution then? If you only have HA minus and if you only have A minus in the solution? No. The definition of the buffer, it is the acid plus the conjugate base, preferably equal values. طيب. Part D, sorry, this is C, D. If you mix N moles of HA and N over 2 moles of HO minus, what will you get? يعني in numbers حتى ما حدا يضيع, أنا عندي 5 HA 2.5 millimole of HO minus. شو بصير؟ 2.5 is the limiting. هيصير عندي هون 2.5. I have equal concentrations or millimoles of HA and A minus. What do you have then? What do you have then? A buffer. Equal concentrations of HA and A minus, I will have a buffer. So yes, this is correct. And to prepare a buffer, you always need, the best way is you always need equal amounts of HA and A minus. How do you get equal amounts of HA and A minus? جيبوا ال HA كيف بدي أقولها, consume half of it. When you consume half of it, when you consume half of HA, محل هيدول الهاف حيبين ال A minus. Okay. Part E. Upon mixing n moles of HA and 2n moles of sodium hydroxide, do you get a buffer? What happens if you mix n of HA to n of HO minus? Mean is an axis. HO minus. Okay, in fact, this will be epsilon. This will be 2n minus n, يعني equal to n. And okay, هيكون عندكم n of A minus. But you have a strong base, which is n, and you have a weak base, which is n. Strong base predominates. Basic solution, it is not a buffer. Understood? Good. Moving to number 43, 45. Yeah. In number 45, consider 500 milliliters of HNO2. Is HNO2 a weak or strong acid? What do you think? Look at the data. عندي Ka given, it's weak. Calculate the mass of NaNO2. What is NaNO2? هي basically NO2 minus, it's the conjugate, لأنه Na plus is a spectator. Required in order to obtain a buffer solution of pH equal 4. So what I know is I need a buffer solution عنده pH equal 4. Okay, buffer Henderson Hasselbalch, pH equals 4. بكل بساطة. Buffer, it means that pH is equal to pKa plus log NO2 minus divided by HNO2. اتفقنا? Now this buffer has a pH of 4. This is the pH that they want. Is equal. What is the pKa? It's minus log del Ka 4.5 times 10 to the negative 4 plus log. كتير منيح. NO2 minus is my unknown. I don't know how much I need. HNO2 is basically how much? 0.5 molar. So that's 0.5 molar. What is your unknown? NO2 minus. Find NO2 minus. NO2 minus will be around how much? Come on, people, calculator. How much? How much? 2.25. Thank you. حطوا الكالكوليتر حالكم وبلشوا حل. Okay. So this is the concentration of NO2 minus. هلا انتبهوا على تك صغيرة. هيدا concentration of NO2 minus, it originated from NaNO2. هون it's important to know whether you have a binary salt, a tertiary salt, etc. Okay. It originated from NaNO2. So basically, after you find this, بتروحوا لهون. What was the origin? NaNO2 yielded Na plus NO2 minus. انتبهوا. 1, 1, 1. I can say the concentration of NO2 minus divided by 1 is equal to the concentration of NaNO2. كمان divided by 1, which is equal to 2.25. ليش عم سوي أنا هيدي الطريقة? Because you cannot use the molar mass of NO2 minus. They did not ask for the mass of NO2 minus, they asked for the mass of NaNO2. Remember that. So if I have the concentration now of NaNO2, بكل بساطة, what I do is this concentration اللي هو 2.25 molar is equal to the grams of NaNO2 divided by the grams per mole of NaNO2 انتبهوا times the volume of the solution. The molar mass of NaNO2 it's 69. The volume ما غيروش على فكرة حطوا بس 500 milliliters so that's 0.5 liters. Find the mass in grams. What is the mass then? تطلع تقريبا I think 78 grams. Okay, أكيد find 77.625. Okay, so 77.6. Pay attention to this trick. Okay, let's go to 46. If you have any emergency questions, simply ask them on the chat أو ارفعوا إيدكم. Question 46. Calculate the pH of the solution prepared by adding HClO4. افترضوا أنا ما بعرف شو هي ال HCl4 بتطلع على given. Do I have it given؟ ما عندي إياها given. لاحظتوا؟ I don't have the pKa of HCl4 given. It means this is a strong acid. To 2 liters, this is the volume of a solution composed of CH3COH and CH3. شو هي CH3CONA? It's the base. CH3COONA. You have Ka only of acetic. The first thing that you do is ask yourself, أنا عندي a strong acid, and the strong acid is added to a mixture of conjugates that contain the acid, acetic acid, and its conjugate base. طيب, هيدا الacid will react with whom? An acid reacts with an acid. So what will it react with? Will it react with this one or this one? The acid will react with the base. If you have all of these given, لحالكم تقدروا تعرفوا إنه the reaction that is taking place هي ال HClO4 plus CH3COO minus. This is the reaction. And to make things easier, بلا ما أحط ال HClO4 هكتبها هيك. It's basically a strong acid. All strong acids are written as H3O plus CH3COO minus. It's a strong acid plus a weak base. The reaction has to be complete. Even if it's not, assume that it is. CH3COOH plus H2O. This is the reaction that is taking place in your system. Okay? And now do the reaction. You have an initial, you have the change, and you have the end, since it's a complete. Initially, the H3O plus was 0.25 mole. حددوا إذا مول ولا mole per liter. Okay? And the base 0.4 mole per liter times 2 liters. So that's 0.4 times 2 كمان mole. The acid 0.5 times 2. هيدي الانيشال لأنه أنا عم بشتغل هون بالمولز. The mole is basically C times V. The change, if you want to know the change, look at the limiting. 0.4 times 2, this is 0.8. 0.5 times 2, this is 1. And you have 0.25. Mean the limiting, this is your limiting value. Remove the limiting value from all of them. يعني minus 0.25 minus 0.25 plus 0.25. What you lose in the reactant is gained by the product. This will be a value of epsilon. This will be a value of 0.8 minus 0.25. So this is basically 0.55. 1 plus 0.25 is 1.25 kilon in mole. Now find the pH. To find the pH, what do you have in your solution? In my solution, I have the acid and the conjugate base. I can simply say that the pH is equal to the pKa plus log البase CH3COO minus divided by the acid CH3COOH, which is equal to Ka, pKa هي minus log Ka, okay? Minus log 1.8 times 10 to the power negative 5 plus log concentration of the base is basically 0.55 divided by 2. ليش بدني احط ال 2؟ لانه بعرف انه في ناس حيبلشوا يغلطوا ليحولوا بين mole و concentration. Okay, divided by the acid, which is 1.25 divided by 2. So remember, in Henderson-Hasselbalch, you don't have to divide by the volume because they cancel. Only in Henderson-Hasselbalch. And this will give you a pH of around 4 point something. It's around 4.39. 4.388. Thank you. And this is how you find the pH of a buffer reacting with a strong acid. Number 47. وانتبهوا على number 47 please. In number 47, you mix 30 ml of HCl. Don't pay attention to the concentration now, just focus on the species. With that channel 3, which is also an acid, اثنيناتهم strong acids. And 40 ml of the base, strong base. The total volume is completely to 1. So the total volume of the solution is 1. What is the pH of this mixture? To calculate the pH of this mixture, I need to react acids with bases. However, remember that you have two strong acids. Strong acids, اللي هن ال HCl, will be completely converted into H3O+. And the HNO3 will also be completely converted into H3O+. أنا ما في يكون عندي two separate values of H3O+ in the system. So you simply say in the H3O+ total in the system, and you can only do this, remember, from acids, because as strong acids are completely converted into H3O+. Yes. So H3O+ total is basically C of the first acid. خلينا نقول هيدا 1 وهيدا 2. It's basically C1 V1 plus C2 V2 divided by the total volume that they placed. The 1 is HCl, which is 1 over 3 times 30. هيدا CAVA أو C1V1 plus the HNO3 is basically half times 20. And it's all divided by the total volume, which is 1 liter. هون بدنا ننتبه. عندي 1 liter وعندي milliliters above. 1 liter, milliliters above. So this is in milliliters. This is in milliliters. You have to change into liters. Okay, you basically get 30 over 3, which is 10, 20 over 2, which is also 10. So that's 20 divided by 1, 20. حولوا لليتر. So that's 20 times 10 to the power negative 3 mole per liter, which is 0.02. Yes. Now find the HO minus total in your solution. If you look at it, there's only one source of HO minus. اللي هي basically 40 ml times 1 over 4, again divided by the total volume اللي هي 1 liter. So it's 10 times 10 to the power minus 3 mole per liter. So now you have in your solution H3O plus, HO minus, react both. The reaction taking place is H3O plus HO minus in a complete reaction to give me 2H2O. The H3O plus is 0.02 ال HO minus is 0.01 أكيد initially. Okay. At the end دغري mean is the limiting, it's HO minus. So H3O plus will be 0.02 minus 0.01, which is equal to 0.01. HO minus is epsilon. pH is equal to negative log 0.01, which is equal to 2. And that's your answer. It's very simple. All you have to do is understand what's happening in the solution, add what you need to add, subtract what you need to subtract, find the remaining species, and find the pH from that remaining species. Okay, 48, and then we go to titration. So 48.1. يلا دي أو نجاوب على السؤال، بس عم نجاوب على أسئلة بس لحتى نخلص هيدول الاثنين. Okay. So 48.1 because it's the same idea. خلينا نقول 0.05 moles of NaOH are added without any changes in volume to 1 liter, so the total volume is actually 1 liter of a weak acid solution of concentration 0.1 with pKa. You have a weak acid, خلينا نسميه HA, and this weak acid is being reacted with HO minus. Okay, دغري اكتبوا reaction. It means it will give you A minus and H2O. Very simply. And they want the final pH of the solution. By the way, this is similar to titration, بس ما عاملينه titration, حاطين لكم إياه one step. Initially, you have the acid, which is 0.1 mole per liter. بما إنه the volume is constant, it's not being changed, I can work with molarity instead of moles. HO minus is 0.05 moles per 1 liter, so that is 0.05 molar. The change, خلينا نكتب the change. Which one is limiting? HO minus is limiting. All the system will lose a value of HO minus, the products will gain it. So that's minus 0.05 minus 0.05 plus 0.05. I don't care about H2O. At the end, 0.1 minus 0.05 is basically 0.05. 0.05 minus 0.05 is 0 or value of epsilon. A minus is 0.05. Without calculation, what is the pH? Without calculation, what is the pH? Without calculation, what is the pH? Because you will notice that in your system, you have equal amounts of HA and A minus. When you have equal amounts of the acid and the conjugate, this is a buffer, pH is equal to pKa اللي هي 5.2. ما تضيعوا وقت وتكتبوا الهندرسون هاسلباك. It's enough. It's enough to notice إنه هيدول two are equal. Understood? Good. 48.2. 100 milliliters of water is added to the final solution obtained in the above problem. زدنا 100 milliliter. What is the pH of the final solution? What is the pH of the final solution? If you dilute. رجعوا للconcept. Does dilution affect the buffer? Does dilution switch the pH of the buffer? Buffers are not affected by dilution. Strong acids are. Weak acids are. Strong bases are. Weak bases are affected by dilution لأنه بالنهاية عم بتغيروا the value of H3O plus أو HO minus. In buffers, what's controlling the pH هي ال HA وال A minus. As long as HA and A minus remain the same, حتى لو عملتوا dilution. For example, if you dilute تنقول a factor of 10, بتصير الفاليو لل HA 0.005. طيب بنفس الوقت ال A minus كمان صارت 0.005. What you did to HA you did to A minus because you are in the same system. They remain equal, pH remains the same. He, it remains the same. Understood؟ يلا خليني اخد السؤال اللي موجود قبل ما اكفي بنمبر 49. مين اللي عنده سؤال؟ مامزيل زينب.
Yes, doctor. B 47. Why the V total wasn't V1 plus V2?
Because they said that the total volume is completed to 1 liters.
يعني I didn't consider يعني الvolume للtwo acids للbase
The
and acid.
total volume is completed to 1 liter. حطوا 20 plus 30 plus 40. Okay, so that's basically 60 plus 30, 90, and then they completed this volume to 1 liter. They are considered, yes, بس بلا ما يتركوهن عن 90, they completed the volume to 1 liter.
Oh, okay. عشان هيك I consider the final volume.
Yes.
Okay, thank you.
Okay, yeah. Back to number 49. وهون pay attention. خلينا بس add a page. I need a page. Let's take this one. In number 49, recognize the titration of 50 ml of CH3COH. Always ask, this is a weak acid. Hold on. Do we always consider a reaction between a strong and weak species is always complete without calculating Kr? Yes. Okay, in most cases, yes, unless they ask you. Because then you have to assume that the pKa of the strong is basically 0. Okay, if we a choice of pH equal 1.9, we should choose it right. What choice of pH equals 1.9? Why would it? Okay, خلي السؤال لبعد شوي. Recognize the titration. أو عيد صياغة السؤال شوي لأنه بالمرة مش مفهوم. Recognize the titration of 50 ml of the weak acid CH3COH with the base HO minus. Pay attention that we introduce a value called X, and X is basically the volume of the base added divided by the volume equivalence. لاحظتوها؟ X is basically the volume of the base added at every point divided by the volume equivalence. وكلنا بنعرف إن volume equivalence has only like one value for every case. And X notes the degree of progression of the titration. X tells you where you are in your titration. If you are at 0, if you are before equivalence, if you are after equivalence, if you are at the half equivalence, X will tell you all of that. Okay, let's start with the reaction step by step. Write the titration reaction. You have the pKa given. Good. أنا بروح لهون. This is question 49, part A. The titration reaction is basically the acid CH3COOH plus the base, the strong base, in a complete and unique manner to give me the conjugate base CH3COO minus plus H2O. This is the first part. This is the titration reaction. Calculate the pH for VB equals 0, VB equals 12, VB equals 25, and VB equals 50. اتفقنا؟ And then give the expression in terms of X. أول شيء من ال X خلينا نعرف نحن على أي point موجودين. If you are at X equals 0 وتذكروا إنه ال X هي الفوليوم للبيس added divided by the volume of the base at equivalence. If it's 0, يعني 0 milliliters added. If X is 0.5 into when? What does it mean that x is 0.5? When x is 0.5, it means x is half. Half, it means that you have added half the amount of the equivalence point. It means you are at half V equivalence. شو بيكون عندي أنا at half V equivalence pH equal pKa. بكل الأحوال حنرجع نحلهم. At x equals 1, the volume of the base added is equal to VB equivalence. You are at the equivalence point. This is important. This is why x allows you to solve very quickly. And if x equals 2, you are after equivalence. For right now, خلينا نعمل calculation لل pH according to the volumes that is given. Okay, so part B. أول شيء, for x equals 0, يعني ال V of the base added is basically 0. يعني ال pH is controlled by the weak acid. Okay, the weak acid. pH, how does the weak acid, في بالسيستم بس weak acid, how does the weak acid control the pH? By dissociating with water to give you CH3COO minus plus H3O plus. The pH of the system is a result of this because you only have the weak acid. That is it. So now the pH, we can say it's equal to half pKa minus half log C. If it is less or equal than pKa minus 1. Remember that. Half pKa. What is the pKa given? 4.74 divided by 2 minus half log C اللي هي 5 times 10 to the power negative 3. You get 3.52. Is it less or equal than 3.75? Yes. This is your pH. هيدي ال x equals 0 أو خليني أقول ال v equals 0. Now part B, خليني أقول 1 2 for v equals 12.5 ml. That's the second one. Okay, 12.5 ml يعني x equals 0.5. This is the half equivalence point. It means that the pH must be equal to the pKa, and it's equal to 4.75 ولا 4? I think it was 4. بكل بساطة. Why؟ مرة واحدة حنقولها بعدين خلص بدكم تكونوا عارفينها دايما. Okay? Why? Because when you take CH3COOH and HO minus, CH3COO minus plus H2O. Okay? Initially قد ايه كانت ال CH3COH؟ خلينا نشوف ال volumes. 50 ml 5 times 10 to the power negative 3. Okay? And 10 to the minus 2. يلا. 50 ml times 5 times 10 to the power negative 3. This is 12.5 times 10 to the power negative 2 because it's 10 to the negative 2. هيدي على 12.5. Okay? In millimoles. This is initial. The change will of course be the limiting. So this is 50 times 5 times 10 to the power negative 3 minus 12.5 times 10 to the power negative 2 minus 12.5 times 10 to the power negative 2 plus 12.5 times 10 to the power negative 2. Okay, you get finally 50 times 5 here, basically 25 times 10 to the power negative 2 minus 12.5 times 10 to the power negative 2. يعني it's 12.5 times 10 to the power negative 2. هيدي epsilon, and this is 12.5 times 10 to the power negative 2. ما بكفي دغري. The acid has an equal concentration to the base. That means pH is equal to pKa اللي هي 4.74. Instead of wasting time doing all of this, simply pay attention to x. simply pay attention to x. X is 0.5, you know you are at the half equivalence point, and then you know that the pH is equal to pKa. بكل بساطة. Just pay attention إنه x is equal to 0.5. Now, the third one is V is equal to 25 ml. Pay attention to x. What does 1 mean? What does 1 mean? X is basically V base added divided by the V equivalence. For x to be 1, you are at the equivalence point. You are at the equivalence point. What do you have at the equivalence point? At the equivalence point, CH3, COOH has been completely neutralized. Neutralized with mean with HO minus, which has completely disappeared. Only CH3, COO minus exists. CH3, COO minus is a weak base. It will render the solution basic. It will render the solution basic. But what is that basic pH? Very simply, pH is 7 plus half pKa plus half log C. If it's greater or equal than pKa plus 1, you only have one thing missing, C. It's 7 plus half 4.74 plus half log. Is it the same C as the acid? Remember, we have something called the conservation of mass. يعني هو basically conservation of number of mole. But concentrations change if the volume changes. So if you say this is 5 times 10 to the power negative 3, this is incorrect. Because the volume changed. In fact, now CH3CO minus, according to the conservation of mass, it's actually equal to the initial concentration. How much was it? 50 times 5 times 10 to the power negative 3, but divided by the total volume, which is basically 50 from the acid and 25 from the base, which is equal to 3.33 times 10 to the power negative 3 molar. أكيد خدوا more than just two numbers. خلينا ناخدها 334. This is the correct concentration that you use. When you say that the acid has been completely converted to the conjugate base, you are right. The mass, the number of mole, conservation of mass, the number of mole. However, the concentration didn't change because you simply changed the volume from 50 to 75. So always find the new concentration of your species in your solution. And then use this to find the pH. 7 plus half pKa plus half log this C will give you 8.136. Is it greater or equal than 4.74 plus 1? So that's 5.74. Valid. This is your pH. Okay, go to part 4. For x equals what? What was the new x? 2. Even if you don't have the volume, given, from x you can calculate it. Is it x2? It means that you have double the volume added. X هي V divided by V equivalence. If it's equal to, and the V equivalence is 25, it means the volume added is equal to 50. Volume added is equal to 50, mean in excess HO minus. Simplify the remaining value of HO minus. Okay, مش كل شوي بنكتب الرياكشن وبنضيع وقت. The remaining value of HO minus is equal to the initial value of HO minus added اللي هي CBVB. What is CBVB? دي كانت ال concentration of HO minus. It was what? It was around 10 to the negative 2. Okay, so that's 50 times 10 to the negative 2 minus CAVA. Minus CAVA. دي كانت the concentration of the acid and the volume. Okay, he basically CBVB minus CAVA. Okay, which is 0.25 divided by the total volume, which is 50 plus 50 milliliters. You can either change to liters أو أنا هون جبتهم in millimole. هي بالنهاية هيدي millimole. Okay, that's HO minus. pH is equal to 14 plus log. Basically, it will be 0.5 minus 0.25 divided by 100. Millimole, milliliter, milli will cancel milli, you don't have to change. So the pH is equal to 11.99. You sure? Okay, 11.99. And that's the pH. بكل بساطة. pH at every stage. Okay? Go back to this part. Give the equation of pH as a function of x for 0, 1 and greater than 1. And this is very important because it will help you calculate much easier. Okay? So تابعوا معي هون شوي. Part C. For x between 0 and 1, it means that you are before the equivalence point. Okay? And we can do something very easily هون. يلا بس هيدا وبدنا نوقف اليوم. عطوني بس دقيقة. يلا 1 minute. نرجع ناخد الأسئلة أكيد. Okay. So before the equivalence point, the pH I know normally is equal to pKa. هيدي من اللي تعلمناها plus log. Before the equivalence point, HO minus is limiting. So basically the conjugate base produced, okay, will be CBVB divided by the acid. The acid remaining here is CAVA minus CBVB. It doesn't matter. Is it 39 or 99? Just check the answers. It's okay. It's only calculation. This is the expression of the pH before equivalence. طلعوا لو ما بتكون على part 2 and this is how you found it. Okay? To convert into x, because I know that x is equal to VB divided by V equivalence. And at the equivalence point, I know that CAVA is equal to CB times the volume at equivalence. Okay, it means that the volume at equivalence is equal to CAVA على CB. Put it here. Just put it here. هيدي ال V at equivalence is always valid for monoprotic weak acids. حتى for monoprotic strong acids. So X will now equal VB divided by CAVA VA على CB. okay, بدون هيدا over, so it's basically equal CB VB divided by CA VA. You know that A over B over C over D, here A over B times D over C. It's easy. So this is X in terms of CA VA and CB VB. كتير منيح. Back to the original equation اللي هي pH equals pKa plus log CBVB على CAVA minus CBVB. And what you have to do is divide all of them with CAVA. CAVA, CAVA. So the pH is now equal to pKa plus log CBVB على CAVA, this is X. CAVA divided by CAVA, this is 1 minus CBVB على CAVA, this is X. pKa plus log X على 1 minus X. What is the importance of this? What is the importance of this? An external question. Find the pH at X equals 0.3. If you don't have any other data but the pKa, can you find it? Find the pH at X equals 0.7. Find the pH at X equals 0.5. كلنا بنعرف إنه هيدي الهاف equivalence pH equal pKa. هيدي أسهل وحدة. But at X equals 0.3, without having to calculate the concentrations, without having to calculate the remaining, without having to calculate anything, simply pH equals pKa plus log 0.3 على 0.7. That's it. Can you find it for X equals 0.6? Can you find it for X equals 0.1? Can you find it for all X's? Without having to calculate too much, you can find the pH of a system as long as you have the pKa and X. And as long as X is between 0 and 1. As long as X is between 0 and 1. Okay. What if X is greater than 1? What does greater than 1 mean? It means that you are above the equivalence point. Okay, let's see that. I need a new paper. Okay. بعدنا number 49. But this time for X greater than 1. نرجع نفس الشيء. For X greater than 1. What is the pH expression اللي احنا تعلمناها؟ هي pH is equal 14 plus log ال HO minus remaining. صح؟ هيدي اللي تعلمناها قبل شوي بالderivation اللي هي 14 plus log what is the remaining value of HO minus? هي basically CBVB minus CAVA by VB. Agreed? Equal. Divide above and below with CAVA. It's equal to 14 plus log CBVB divided by CAVA. This is X minus CAVA على CAVA. This is 1 divided by VA plus VB CA VA. Do a little خليني أقول reorganization. The pH is now equal to 14 plus log X minus 1 plus log CAVA, هدول the original values that you have of the acid, divided by VA plus VB. And that's it. If you have X وأكيد حيكون عندكم the initial value of CAVA, you can simply find the pH using this formula. Very easily. طيب. The last part, draw the shape of the titration curve. هلا نحن حنرسم titration curve, and at the same time we're going to look at all the regions. Okay? So pay attention here. We're going to separate all the regions. So let's see. Okay. Volume of the base added, pH. The general shape of a weak acid will give you an inflection point, will continue into a buffer region, go into a vertical jump, then go into a plateau. The general shape of a pH curve. خلينا نبلش من the first point. At this point رح نسميها 1. V equals 0 milliliters. Okay, this point is 1. V equals 0 milliliters. We can find easily the pH for an acid. He half pKa minus half log C. Okay, we're gonna do this point, which is basically your V equivalence. This point, which is basically your V equivalence divided by 2. هيدول أهم points عندي أنا. Okay, we can divide it into regions. This region is X between 0 and 1. This region is X greater than 1. هيدي point 2. منبلش. At point 1, it's only CH3COOH that exists. أكيد when I say only CH3COOH exists, ما تنسوا إنه CH3COOH will actually dissociate in water ليعطيني CH3CO minus مع H3O plus. ما هيدي الانفلكشن اللي أنا بشوفها هون. أوكي. سببها إنه عندي H3O plus بالسيستم، and هيدي ال H3O plus originates from CH3COH. So خليني أنا أحطها بهالطريقة. At point 1, this is what controls the system. And you already know how to find the pH of this. Half pKa minus half log C أكيد كفوا validity. Point 2. Point 2 is VE divided by 2, which is the half equivalence. At this point, the concentration of CH3COOH is always equal to CH3COO minus. pH is equal to pKa. At point 2, pH is equal to pKa. At point 3, and this is the equivalence point, the acid has been completely neutralized by the base. I have in my system is CH3COO minus exists. When I say CH3CO minus exists, يعني this controls the system. هيدي الرياكشن. It means that your pH is equal to 7 plus half pKa plus half log C. Don't forget to find the new concentration اللي هو C. هيدول the easiest point in the graph. You have one more point, which is basically مش point, you have one more region, which is basically the x between 0 and 1 and the x greater than 1. For x between 0 and 1 شو ما كانت الفاليو للx انتوا بتعرفوا انه هون you are before equivalence. شو ما كانت الفاليو of x, the pH is equal, هلا طلعنا derivation, it's equal to pKa plus log x divided by 1 minus x. For x greater than 1 pH كمان هلا طلعنا derivation هي pKa plus log حنكفيها هون x minus 1 plus log CAVA على VA plus VB. You have one more point that is important to know, which is actually for x equal to. خلينا نحطها هون. هلا مش هتطلع شوي equidistant بس. For x equals to this point, you have 2VE. Two VE is an important point to know because you can derive its equation as well, like we did for x home. And this point is usually asked for. So this is number 49. اللي عنده سؤال يرفع ايده نشوف اذا بنقدر نكفي ونسوي number 50. يلا اللي عنده سؤال يرفع ايده.